In this video, we will demonstrate the application of Monte Carlo simulation for the simulation of correlated stock price using Python. In the previous video, we demonstrate or we explain the theories related to this process. So remember that the simulation of correlated stock price was given by S1 is equal to this formula, and S2 is also given by this formula, where mu1 and the mu2 corresponds to the expected return, and the sigma 1 and the sigma 2 are the volatility. The W1 W2 is Rayleigh process. So the discrete form is also given by this one. Therefore, our objective is to simulate the price process if the correlation rho is given by this one. So the application of Cholesky decomposition can be done in this way. That means epsilon 1 is equal to u1, epsilon 2 is equal to rho times u plus the square root of 1 minus rho squared times v, where u and v are uncorrelated standard normal distribution sampled from this distribution. So we also constructed or we define a Python function known as toStocks, which could take these parameters, and the output is given by this one. That means possible price path for the correlated stock price S1 and S2. We also observed just a scenario where the parameters are given by this one, and we try to simulate different cases. That means where the case rows or the correlations, negative correlation, small positive correlation, and correlation 0.75 and 0.95. So we demonstrate this one, and we obtain these pictures or these plots, which is very interesting. So the objective of this video is to implement the Monte Carlo simulation for predicting the price process of two stocks. Now we import first this package, import yfinance as yf. This is important for downloading data from Yahoo Finance database. Next, select starting and ending day for the data. Start. So 2023, January 2001, ending date 2024, again January 3rd. Then Apple and Microsoft will be selected. The tickers here, Apple and Microsoft. Now we download the data and store it as DF. Ticker from starting date up to the ending date. But we download only the adjusted close price. So downloading is complete. Let us observe what does this data looks like. The first 5 entries. So this is our data. Then the next step is calculate the parameters like daily return, so return is equal to df. We use a built-in function called percentage change in the pandas data frame, and drop if there is no number. So the next step splits the data into two, that means as a training and a test set. So n is equal to length of returns, capital N, and number of training data size integer. We take 90% of the data as training set, and the remaining one as test set. Here we are using similar terms, which is usually popular in machine learning community. So let's say print n, number of training size, and test. As you can see, we have 268 days for training. That means for estimating the parameter will be implemented here, we will take 241 days, and the remaining will be for prediction purpose. And we test against the given data in these 27 days. So this is our data train, okay, from the return. That means we take from the first entry to n train. This is our data for estimating parameters. The remaining will be returns, then n train to the end will be test set. Now parameter for Monte Carlo simulation. Here first the initial price S0 is equal to f dot log test dot index, that means index. So the first entry from the index will be the initial price for the simulation. Okay, so observe that what is S naught of S. Therefore the initial price is 196 and 371. That means for this days, that means we split the data into two. Okay, for this, the first element for these days, for the remaining 27 days. So here S01 will be the first stock price for Apple, and S02 will be S0 for Microsoft. That means we assign the initial price for the Apple, and okay, so the index for the test set. So what is the starting date for this S01 and S02? That is starting date. So the date is here, the 2023, that means December 19. Okay, this is December 19, and December 19 the price was this 2, right? Now the parameters news is equal to returns dot mean, right? That means the news for Apple and for the expected return for Apple and Microsoft. The volatility sigmas is equal to returns dot standard deviation. So let us see what is this sigmas. So the sigmas for, that means the volatility for Apple and Microsoft. Then the correlation, okay, rows or rows. So the correlation matrix is given by this one. So this is the correlation of the close price, by the way. So rows, you can see this one. So we have a matrix, the correlation between the Microsoft and Apple is 0.93 concerning the adjusted close price. So mu1 is equal to mu's of Apple, and mu2 is mu's of Microsoft, and also sigma or sigma 1 will be sigmas of Apple, sigma 2 also sigma. Here I have to copy here first, and Microsoft. And so the other parameter for the simulation is rho. Rho is equal to 0.93 that we already observed, 932, and the number of tests and the test is of 27 days. Then the number of simulation, not number of simulation, just we can set that any number. Let's say let's take n sim is equal to 10. So now we can call the function that we already saw before. Call the function, which is the two-stock function. The two-stocks function. So the output is two data frame, which is S1. Let us call it S1 and S2. Two-stock. So therefore, these are the inputs that we have to insert. The inputs are S01, S02, mu1, mu2, sigma 1, sigma 2, and we have to use correlation, the time capital T, and the number of simulations. So this is what we have, two stocks. Yeah. So once you run this, you will get the simulated. So two stocks here. We have to run this function, of course. This is the function we are going to use. We have to also run the NumPy package, which is here, the pandas data frame also. Now we have to get the right outputs, the correct outputs. So set the index of this S1 and S2 so that the index is in agreement with the test data set, and also calculate the average simulation. Okay, the average of the simulation that we already take. Right here, the average of the simulation. Calculate the average of the simulation. This is for Apple. Okay, S1 mean, and this is for Microsoft. Okay, this is the average. For example, if you take the average for this 27 days, the average simulation given by this quantity is indicated. So here, create a data frame with the average value of each time step and corresponding to actual price. Right. Therefore, here this is for the Apple. Change it to data frame. For Microsoft, change it to data frame. Then join with the real or the already observed price for Apple, right? And also we will do the same for Microsoft. So now we have a new data frame. Now, for example, what is the F1? Sorry, the F1. So this is the simulation of the average simulation for Apple, and the really observed close price and the simulation, right? And also similarly for the second data frame 2. Okay, this table shows the simulated average price for Microsoft, and this is Microsoft adjusted close price for this date, for the indicated date. Lastly, we can plot one by one just how the simulation is very good. So this is the first plot. You see, of course it is fine, but this is the orange one is the true price, and the blue one is the simulated average price. But in this case, if we see for the Microsoft, it is relatively better. Yeah, this is Microsoft simulated average price, and the orange one is Microsoft adjusted close price. If we want to look at the result in one data frame, we combine, okay, we combine the two data frames. That means this, the F1 and the F2, and we try to see the plot in one figure. Here it is. So now you can see that this is a comparison. That means the two the simulation is performed by calculating the correlation of Apple and the correlation of Microsoft. As you can see, the result is very nice, the prediction is very nice, and it is very efficient when we consider two stock prices which are correlated. Also, we can extend this to more than two stock price by applying Cholesky decomposition method. So this is a continuation of previous video. Try to look at the video in consecutively. Thank you very much.